The ARES 1 NASA rover project, with our technical writer Trey Hamm, our operations engineer Mason Street, our technical engineer Burton Casey, and our design engineer Sophie Ray. Meet ARES 1, the rover we had designed for our project. For our inspiration, as we began our project, we decided we would try an entirely new wheel design from what we originally started with. For our wheel design, we took some inspiration from the Perseverance's tread. We made our own version by adding spikes for tracking and protruding the grousers and turning them into scoops. After designing it in Tinkercad, we prototyped and printed this. However, this would not be our final design.
The challenges faced were not in the wheels, but the chassis itself. Due to either a flaw while printing or the pressure of the spacers, the chassis was deformed, causing the wheels to be at an angle and the motors to go inwards. This also made the spacers loose. To fix this, we added duct tape to the spacers to pad out the spacers and even out the angles the wheels were put at.
Our first wheel prototype, we used mostly simple straws as scoops. At first, it did well, progressing easily through the 0 incline up to the 150 millimeter incline. However, at the 200 millimeter incline, it began to dig in and it didn't manage to make it all the way to the top. This is a prototype design that we had. We tried to go back to a simpler design. We thought it would work better due to its simplicity. However, unfortunately, we were wrong. It made it through the first 4 tests. However, on the 5th one, about 2/3 of the way up, it got stuck in the sand. This is our final design that we ended up sticking with. We improved on the original scoop design by adding spikes to get better traction. This one did end up working the best. It easily cleared test 1 through test 5. On test 6, it began to struggle with the incline and began digging in slightly. On test 7, around the halfway mark, it began to dig in, and unfortunately it couldn't make it all the way up the 300 millimeter incline.
Our results. Overall, the scoop with spikes design performed the best. An issue that we ran into, however, was that many of our wheels designs struggled if the stand was not perfectly level with the incline. We also had many problems with the chassis and wiring, resulting in issues such as one of the wheels failing and lack of motor power. This prompted us to continuously open the chassis, allowing for stray debris to get in and possibly cause more trouble. We are unsure if the failures came from the design of the wheels or the issues that occurred within the chassis. Additional thoughts and information. Due to the fact that we are high school students and thus lacking in certain materials, we had to do the best we could with what we had. SMA, or shape memory alloy tires, are a technology that we as a team hold some interest in. If we were NASA engineers or designers, we would likely opt for such tires.
While none of our wheel designs were able to complete the 300 millimeter incline, they performed decently well otherwise. We may not have succeeded, but we know where we went wrong and how to do better going forward. If we were to do this project again, we'd experiment with different materials and textures, which could give us better traction. In addition to that, we would likely choose a simple wheel design as opposed to trying something completely new, like the law of parsimony. The most obvious choice may have just been the best one.